Hello and welcome back to another video. In today's video, we're going to be covering an introduction to linear equations. So now I know that sounds kind of complicated, linear, you've probably never heard that word. So we're going to try to break this down very simply. We're going to try to explain this to the best that we can. And hopefully by the end of this video, you'll understand how to do and understand the basics of linear equations. So let's get straight into it. So the first thing you're probably wondering, as I know I was when I first learned this, is what does linear mean? So when we say something is linear, that means there's a constant relationship between two variables. And when we plot it on a graph, there would be a straight line. So a couple things to take away, it's constant relationship. You can usually see a straight line. Let's see, is there anything else we should know about linear equations? So now, not that I can think of off the top of my head, I don't have anything in my notes here. So we're going to continue now with how do we tell if a function is linear? So again, as I mentioned just now, a linear equation is something where we have a constant relationship, and it's usually between two variables. Between two variables. So what does that look like? So let's look at a basic equation. So I've already taught you guys how to do basic equations and how to solve equations, but now we're going to do something a bit weirder. So let's say we have an equation like y is equal to 2x plus 3. Okay, so you'll first notice that there are two variables. We have the y and we have the x. So how do we make sense of this? And what does this mean? So essentially what this is telling me, if I was trying to translate this, it's saying that the y, so if you know x and y, as you should know from pre-algebra, this is our x-axis and this is our y-axis. If I'm starting off at this point right here, let's say I'm starting with my graph at 3 on the y-axis, uh, I would be increasing at a constant rate of 2. So I'm going to be going up over 1, 2, like that. But you don't have to worry about how to calculate this yet. I'm just going to show you, if I was to graph this, we would get a straight line. And that is all you should know for the moment. That a linear equation, when we graph it, is going to get you into a straight line like that. So using this knowledge that we now have, let's try to figure out if we can identify which graphs are linear. So let's look at this first example right here for number one. Number one. So is this graph linear? Well, let's think. Is it a straight line? The answer is no, because look, it's curvy. It's a curvy line. It's going all over the place. So therefore, it's not linear. The next one is this one, number two. Is this a straight line? No, it's not a straight line. So if it's not a straight line, that does not make it linear. So therefore, this is also not linear. Let's look at number three. Is number three a linear graph? Yes, it is, because why? It's a straight line. We see a straight line just like the graph I did right here. This was a straight line right there, and we're doing the same exact principle for this one right here. So we can therefore conclude that this one is linear. Okay, so now that we know a linear equation is where we have a straight line, now let's actually look at the components that exist in a linear equation such as this one that I just showed you. And we're going to break down how to understand what this means. So let's see. What components exist in our linear equation? So let's use that same exact one I just showed you. So I had y is equal to 2x plus 3. So the first component we have is called our, we'll just call it y for the time. So the y variable, you may hear it referred to sometimes as the range in your math classes. But range or is just another way to say y. And I'll go more in depth on this in another video, but right now just know that this is y. The next thing we should know is this number in front of the x. And this number right here is called the slope. And what does the slope tell me? The slope is going to tell me how much the value of a line is going to be increasing by each time. So, for example, oh, let me zoom out. Okay, so we had y is equal to 2x as same equation right here. Y equals 2x, and I had graphed that over here. The reasoning, basically what that's saying is that every time we go up and over, we're going to be going up plus 3 and over 1. So plus 3 on the y direction and plus 1 in the x direction. Again, don't worry yourselves too much yet. I'll go over that in a minute. But just know that the slope is the degree to which we are increasing the line as we are going forward. And then the next part is called our y-intercept. So this is our y-intercept. And basically what that tells us is the starting value on the y-axis where the equation is starting. So let's look at the graph of that I just did. So as we can see, on the y-axis, where is the spot that our line is going to be hitting on the y-axis when x is equal to 0? It's at 3, right? So all that the y-intercept tells me is where, um, basically it's saying when x is equal to 0, it gives the y value. And that is all that's happening here, really. So again, you may not understand this at first. Don't feel pressured to understand it yet. I'm going to go into more depth now, and I'm going to keep explaining this in other videos until you guys finally start to understand this. So now that I've covered the components of a linear equation, let's actually go through the different components now and try to figure out if we can understand them better. So let's begin with the slope. So I'm assuming that you guys have learned about slope a little bit in your pre-algebra classes, but just to review, the slope is going to be, you have a formula called y2 minus y1 over x2 minus x1. And essentially what that tells us is, let's say I have 2 points. So let's take 2 points from this graph. So we had 3 comma 0, and we had, I think that's 1 comma 5. Let's try that. Okay, 1 comma 5 and 3 comma 0. So when we have these two point values, we can put that into the equation because remember, if you guys remember, this is x1 and this is y1 and this is x2 and y2, right? These all point to that. So if we did m, which is the slope, is equal to 0 minus 5 over 3 minus 1, that would give me to negative 5 over 2. Oh, wait, did I put the wrong point in there? Let me just double check this real quick. Um, oh, wait, I put the wrong point here. That's why. This is supposed to be 0, comma 3. My bad. So let's just redo that. Ignore what I just said. This point was wrong. So this was 0, comma 3. And therefore, you would have uh, 3 minus 5 over 0 minus 1, which is negative 2 over negative 1, which is equal to 2. And what value is this? This is 2, which is the same as my slope right here. So again, if you have not learned this, I would suggest you review, you look up some articles, look up some more videos on this. I'll probably make another video going more in depth about slope as well. But this is a pre-algebra topic you should have covered by this point, so I'm not going to spend much more time on this, really. But just, yeah, that's your formula right there. I'm going to teach you guys another way. You could probably calculate the slope as well, and we'll try to go quicker. So you could also say that your slope, which is m, is equal to the rise over run. And what that means is that let's say I'm on this graph right here, right? And I want to calculate my slope. What would I do? The thing we could do is we look at this rise over run idea. So how do we do this? So we begin by starting off at some point. So let's start off right here. And I'm essentially going to say, I'm going to look and say, okay, how much am I rising by? Or how much am I going up by? So I'm going to be going up 1, up 2, right? And then after I go up 2, it takes me over 1, right? So this was plus 2. It's going to take me over to plus 1 in the x direction now. Okay, so our rise was equal to plus 2, and our run was equal to plus 1. So remember that rise is y and run is x. So this is just a faster way to figure out the slope if you have not learned that yet. I didn't learn that until Algebra 1, which is what this video is intended for. So if you have not learned it, that's a great way to look at it. The change in your y direction and the rise divided by the change in your x direction or the run. So now that you know that, we found multiple ways to figure out what the slope is. I've reviewed this a bit for you guys. And now we're just going to look at some examples and we're going to put it all together. So we're going to look at this and we're going to try some practice problems. So one more thing before we go to these practice problems is I want to show you guys an example of how we write the slope in Algebra 1. So let's say, let's just look at this again. So y is equal to 2x plus 3, right? We always, when we write our things like this is called our slope intercept form, right? And in slope intercept form, what that essentially means is that the y is right here, the slope is right here in front of the x, and we have a y-intercept right here. That's all we're doing. There are different ways you could write these formulas, but your goal is to always simplify into such a way so that you can get it into this form. So at this point, if you're in these practice problems like for number 1 and 2, you're going to have to use those skills I taught in my last videos about how to simplify linear equations. And you're going to have to use that to figure out how to get this into this form, right? So I want you guys now to pause the video and to try to figure out, I'm going to put that right there. So try to figure out now, how do I do all these problems but using what I just learned? You're going to have to try to apply some stuff that I just taught you and use some knowledge from the past videos. So pause the video right here, figure it out, and come back, and I'm going to show you guys how to do each of these problems. Okay, I hope you guys finished the video, finished doing the problems. Hopefully you got them right. Let's check and see if you were right. So if you're struggling, don't worry, I'm going to break this down for you. So let's look at number 1. It says to write the slope-intercept form of the equation in each line. So again, as I just said, slope-intercept form is we're going to have y is equal to mx plus b. So for example, that one last time was y is equal to 2x plus 1. You have a slope right here, and you have a y-intercept right there. That's what we're trying to do, and we're going to do it right now. So how could I get this to look, how do I get this to look like this? What I can do is I could try to get my y onto one side and then everything else will look like this. That's the rule. So to get everything to look like that, we're going to try to do some simplifying. And we're going to try to move some stuff over from one side to the other. So the first thing we can do is subtract 3x on both sides, right? And then that would leave us with negative 2y is equal to negative 3x minus 16. And then divided by negative 2 on both sides. And then y is equal to 3 over 2x plus 8. And that is your answer right there. So it's not too bad. That is something you should learn right there. So try to get it into this form. We simplify it. We try to get y onto one side just like it is over here. And we're good to go. Let's try another one. With this one, it's very similar idea. You'd subtract 13x because you want to simplify the y onto one side, right? You have a negative 11y left, and that's equal to negative 13x minus 12. And then divide negative 11 on both sides, and y would be equal to 13 over 11x plus 12 over 11. And that is how we do it. So if you didn't get those right, don't worry. It's kind of complicated, but if you do some practice problems like this, you'll be fine. Let's go to our next ones. These ones are pretty straightforward. So again, remember y is equal to mx plus b, where m is the slope. So essentially what this is telling me is that this number in front of the x, when y is on one side of the equation, that number right there that I've circled is going to be our slope. So therefore, we can figure out that negative 5 over 2 is equal to m for this one, and that negative 4 over 3, as we can see right here, is our slope for that side. So those are not too complicated. Just look at the number in front of the x when it's in this form. So I didn't give you guys anything too complicated. If I wanted to give you something a bit more complicated, you could have looked at one of these problems, for example, and been asked to find the slope from that, in which case you would have had to simplify it into this form and then figure out what number is in front. So just keep that in mind. Your teacher could ask you that potentially. So it's a good skill to know how to do. Finally, for this one, I want you guys to figure out if it was linear, the answer would of course be yes, because it is a straight line, which means there's a constant relationship between the y value and the x value. And then bonus, what is the slope? Let's see if we can figure this out. So we start off at a point on the graph. So this was starting off at 0, comma 2, for example. And then we look for another point. So for example, this one, we have 2, comma 0, right? So now we would do our slope formula, which is equal to y2 minus y1 over x2 minus x1. And that is equal to 0 minus 2 over 2 minus 0. That's equal to negative 2 over 2, which is equal to negative 1. The other way you could have done it is my rise over run method. Remember that? So we would look basically and we would see, okay, how much are we going down by? So we're going down by 1, going down by 2. So we're going by minus 2, and we're going over 1, 2. So we're going over 2, and okay, so it's minus 2, and this is the plus 2, and then that would equal to negative 1. So you could see either way would get the same answer, would get our slopes. Okay, so in my next video now, I'm going to try to elaborate on this kind of topic now. We're going to go a bit deeper, and we're going to try to explore a bit more complex relationships with these, and I'll try to explain anything else I didn't explain in this video. Thank you so much for watching. Have a great day.